Hello my dear students, today we are going to discuss about our ray optics fifth lecture, and in this lecture we are going to discuss about different rules formed by concave mirror and convex mirror. So first of all we are going to take our concave mirror, and this is our concave mirror, and we know this is our principal axis, and this point is called pole. Okay, and here is focus and here is center of curvature. When the incident light ray coming parallel to the principal axis, then after reflection it reflect from the point which is called focus. So this is our first rule. If light ray incident parallel to the principal axis, then after reflection it bounce back, it reflect from a point is called focus. This is our rule number 1. Okay, first of all we are going to discuss about concave mirror. Okay, so this is our rule number first, and the rule number second is that when the light ray coming at focus, then after reflection it pass parallel to the principal axis. Okay, this is our second rule. Okay, what is second rule? When the light ray coming to the focus, then after reflection it pass parallel to the principal axis. And the third rule is that when light ray coming at center of curvature, then it bounce back in the same medium at same path. Okay, so this is our rule number third. When light ray coming at the center of curvature, then after reflection it will pass from center of curvature. And one more rule we have to learn, which is rule number 4, and this rule is said that when a light ray coming at some angle to the pole, this is our pole and this is our, suppose this is our angle theta 1, then if incident light ray make an angle theta 1 with the pole and principal axis, then after reflection the same angle will be formed by reflected ray with principal axis. So here the theta 1 is equals to theta 2, because incident angle equals to reflected angle according to laws of reflection. So these are the rules formed by concave mirror. We revise it. When light ray is coming parallel to the principal axis, then after reflection it reflects from the focus, and when light ray is coming to the focus, then after reflection it went parallel to the principal axis. Okay, and the rule number third is that when light ray coming to principal center of curvature, then it will reflect at the same path from center of curvature. And the rule number is 4 is that when light ray coming at some angle from principal axis, then it will make same. Okay, we are taking different cases for concave mirror, and this is our concave mirror, and this is our principal axis, pole, focus, center. When object is placed beyond C, means center of curvature. Okay, when object is placed beyond C, when we put the object beyond C, then we take minimum 2 rays for making image. So first of all we are taking the first ray, and the first ray is coming parallel to the principal axis, then after reflection it will pass from focus. This is our rule number first. When light ray is coming parallel to the principal axis, then after reflection it will pass from the focus. And one more ray we are taking, and this light ray is coming to the focus, then after reflection it will pass parallel to the principal axis, and this reflected ray, Okay, this reflected ray meet at some point, and here this point is called A dash O dash. Okay, so here OA is our object and O dash A dash is image of this OA object. One more time we revise it. When the light ray is coming parallel to the principal axis, then after reflection it will pass from the focus, and another ray is coming to the focus, then after reflection it will pass parallel to the principal axis. So we write about the some points about this image. This image is formed between C and F. So first of all we write this image formed beyond image formed between C and F. Image formed between C and F. Image is formed. Here we see that the image formed is in between C and F. And size of image is diminished. We can also say that size of image is smaller than size of object, and the image formed is real and inverted. Why we say that the real and inverted is formed? Because when the light rays after reflection cut in reality, then these images are called real images. And here we say that we do not need to produce backward and we do not need to meet them. So here we see that the light rays after reflection they automatically meet at some point. So we say that this is our real image, and we know that real image is always inverted, and we say that here is object and image is inverted. So we say that the image formed is real and inverted. And another point is magnification. What is magnification? Magnification is represented by small m, and the formula of magnification is height of image to the height of object. Okay, here we see that suppose the height of image is 2 cm and height of object is 4 cm, and we put height of image is 2 cm and height of object is 4 cm. And according to our sign convention, if we take upward, so we take positive sign, and when we go downward, then we say negative sign. So height of image is negative and height of object is positive. So we get here magnification is in negative sign and magnification is less than 1. So we consider here 2 points, which one is magnification is negative. We are taking just values. It's not exactly 2 and 4. We are just taking the examples. Suppose the object is 4 cm and image is 2 cm. Then height of image is 2 cm and height of object is 4 cm. Then we get the magnification is minus 1 by 2. Means magnification we get in negative sign, and its magnitude of the magnification is less than 1. So we see the complete information about the concave mirror when object is placed beyond C. Okay. Now we consider the second case of this concave mirror when object is placed at C. Okay. So let's see. When object is placed at C. Okay, see here, this is our concave mirror, and this is our principal axis, this is pole, and this is focus. Okay, now this is our center of curvature, focus, and this is pole. Now we are going to put the object at C. Suppose this is our object, okay, point OA, and when light ray is coming parallel to the principal axis, then we know it will pass from the focus. This is our rule number first. And when light ray is coming at the focus, then after reflection they will pass from the they will pass parallel to the principal axis. And we know that when the light ray is coming parallel, then it will pass from the focus, and when light ray is coming to the focus, then it will pass parallel to the, and when this reflected ray meet at point, and this point is called O dash A dash. Okay, suppose see here, when a light ray coming parallel, then after reflection they will pass from focus, and when light ray is coming to the focus, then they will pass from parallel to the principal axis, and these reflected rays meet at the common point. This common point is called A dash. Here OA is our object and O dash A dash is our image. Okay, so we are writing here some points about this image formation. So first of all, we see that the image formed at center of curvature. This is point of our center of curvature. So first of write, image is formed at C. Okay, image is formed at C. Okay, and another point is the size of image is equal to the size of object. So image is same size of object. Okay, image is same size, object size and image size are equal, means image is formed same size of that of object. Okay, now third point is the reflected ray meet in reality, so the image form is real, and we know that real image is always inverted, and we can see that here our object and image is formed inverted. That's why we said that the image form is real and inverted. And fourth and most important point is our magnification, and we see that magnification formula is height of image and height of object. Here we say that the size of object and size of image are same. That's why we say that suppose we take the object of 4 centimeter and image is also formed 4 centimeter, then minus of 4 and 4. Minus of 4 we are taking because the size of height of object consider positive to the principal axis. Upper side of the principal axis taken as positive and lower side of the principal axis taken as negative. Here object is put on the principal axis upper side, so that's why we take a positive sign, and here the image is formed lower side of the principal axis, that's why we take negative sign. So magnification m equals to minus 4 by 4, so we get magnification minus 1 here. Okay, and we see that the magnitude of the magnification is 1. Okay, so we consider these 2 points are most important. Here we get magnification negative and magnitude of magnification is 1 when the object is placed at C. Okay, now we consider the next case, which is when object is placed between C and F. Okay, let's see the third case. Case third is that when object is placed okay between C and F. Okay, see here, first of all we take rule number case first, when the object is placed beyond C. Second case, when the object is placed at C. And now we are taking the third case, when object is placed between C and F. Okay, now we are taking the case third, which is between C and F. When the object is placed between C and F, then take ray first, okay, and this first ray coming parallel to the principal axis, then after reflection it will pass from the focus, and another ray we are taking to the focus, then it will pass parallel to the principal axis. Then these light rays meet at this point, and suppose OA is object, then O dash, A dash is image, and we put some points. Okay, so the point first is the image formed at O dash A dash, which is beyond C. So image is formed beyond C. Okay, here in this case the image is formed beyond C, and size of image is larger than size of object. Okay, so image height is magnified. The image is magnified. Image is magnified. Okay, now third point is image formed is magnified image. Okay, and third point is the image is again real and inverted because reflected light rays actually meet at this point. Okay, so image formed is real and inverted. Okay, image is formed real and inverted because reflected light rays meet at this point real in reality. That's why we take real and inverted image. And fourth and most important point is magnification, and the formula of magnification is height of image to the height of object. Okay, here we are taking height of image hi, and this is our height of object. We say that we see that height of image is larger than height of object. Suppose we are taking the height of image is 10 centimeter and height of object is 5 centimeter. Suppose is height of object is 5 centimeter and height of image is 10 centimeter. Then we get the magnification. We are just taking for example, not its real values. So we getting the magnification is greater than 1, means magnitude of the magnification is greater than 1 and magnification is positive. Okay, so in this case we see that the magnification is positive and the magnitude of this magnification is greater than 1. Okay, what is this case? When the object is placed between C and F. Okay, now we are going to take fourth case, which is when object is placed at F. Okay, so our fifth case is case fifth. This is our concave mirror, and this is our focus, this is our center of curvature. For in rule case first we put the beyond the center of curvature, in case second we put at center of curvature, in case third we put between C and F. Now we are going to put when object is placed at F. Okay, when object is placed at F. Object when we are going to put on focus, then take when light ray is coming parallel to the principal axis, then after reflection it will pass from the focus, and here we do not pass from light ray from the focus because the object is placed on the focus. That's why we are using our rule number 4. When light ray is coming at some angle with the principal axis, then light ray after reflection going from the same angle as the same incident angle, and these light rays making the same angle with the principal axis. That's why these light rays are going parallel, and parallel light rays, we say that parallel light rays meet at infinity. Okay, these light rays are parallel and these parallel light rays meet at infinity. So we say that the image is formed at infinity. Infinity means very far point as compared to the aperture of the object, means dimensions of concave mirror as compared to the dimensions of the concave mirror, the image formed larger distance than the comparison of the dimensions of the concave mirror. Okay. Now second point is image formed at infinity. Okay, and when these images we consider they meet, then the image formed is highly magnified. Image is highly magnified image. Okay. Now the third point is image, again they meet at reality. So this is our real, and we know that real image is always inverted. So the third point is image is real and inverted. And fourth and most important point, which is our magnification, which is height of image and height of object. And magnification, height of image, we see that the height of image is much larger. The height of image is much larger than height of object. Suppose we are taking the height of image is 2 and height of object is 2 and height of image is 10, and again we put the negative sign here. Okay, again we put the negative sign here. So we put magnification -5. So in last case also the magnification is negative. Okay, in last case when we put C object between C and F, then also magnification negative. I think I forget the negative sign there. So magnification is negative. Magnification is negative in that case also, and magnitude of magnification is greater than 1. Okay, magnitude is greater than 1. Okay, magnitude is greater than 1 and the image magnification is negative. Okay, and one more point, when object is placed case sixth, when object is placed between pole and focus. Okay, see here, this is our concave mirror and this is focus, this is center of curvature and this is pole. And when light ray coming, object is placed now between pole and focus. Okay, when light ray is coming parallel to the principal axis, then after reflection it will pass from the focus. This is our rule number first. When light ray is coming parallel to the principal axis, then it will pass from the focus. And third point, second point we are taking, when light ray is coming to the center of curvature. When light ray is coming to the center of curvature, then it bounce back with the same path and it will pass from the center of curvature. And these light rays, we say that these are the diverging light rays. And we know that diverging light rays never meet to any point. So we produce backward. These light rays we produce backward, and these backward light rays meet at some point, and this point is our image point. So this is our A dash and O dash. Okay, so the only one case of concave mirror where we get the virtual image behind the mirror. In all the cases we are getting the real and inverted image, and in real and inverted image the magnification is always negative. When we get the real and inverted image, then you always say that magnification is negative. When we get the virtual image, then we say that the magnification is positive. This is our rule. We can learn this by using this concept that in daily life we think about negative. So in real life we think about negative. So this is our negative. Okay, so magnification is negative. And in virtual life we think positive. So this magnification is positive. So real image when formed, then magnification is negative, and when virtual image is formed, then magnification is positive. Okay, so here first image is behind the mirror. behind the mirror. This is the only one case where we get the image is behind the mirror. Okay, in other all the cases we get the image in front of the mirror. Okay, and this here the light rays is not actually meet, these are the diverging light rays. That's why we produce backward, and backward light rays meet at the common point, and that's why these are the virtual image. Okay, virtual image, and virtual image is always erect. Okay, erect means okay, same side, same as object. The object is placed here and image is formed same, so image formed is virtual and erect. Okay, image is behind the mirror. Okay, and virtual and erect image, the height of the image is larger than the height of object, means height, size, we can say that size of image is larger than object, means magnified image we can say. And here we see that magnification is height of image to the height of object, and here we see that the height of image is, suppose we are taking the object size is 4 centimeter and image is formed 8 centimeter, then 8 by 4, and here we sign both positive because both images are formed upward side of the principal axis. That's why we are taking the magnification is 2. So we say that mode of magnification, magnitude of the magnification is greater than 1, and magnification is positive. Okay, magnification is positive. So in case of concave mirror, we get each type of image: real inverted small size, real inverted same size, real inverted large size, real inverted very large size. But in last case, when image is formed between pole and focus, then we get virtual image and virtual erect image. So that is the only one case where we get virtual image. Okay, so we take the fast revision of this all the cases. How you learn after reading this all the cases, I give you some trick so you can learn easily. Okay, let's see. This is our mirror, concave mirror, and this is our principal axis and its pole and focus. Okay, and see that here when we placed object beyond focus and center of curvature, and this is our pole. When we placed object beyond center of curvature, then image is formed between C and F and small in size. When we object at C, image is formed at C of same size. When we placed object between C and F, then image is formed larger size. When we placed object at F, then image is formed at infinity. Image is formed at infinity and very large size. So what we see here, when object move towards the pole, then image is moved backward and the size of image is increasing. So we say that when the object is moved towards the pole, then image is moved away from the pole and the size of the image is increasing. That's only one case which is most important, when object is placed between pole and focus. Then in that case the image formed is virtual, erect and magnified. Virtual, erect and magnified image, because the image formed here and this image is virtual and all other images are real inverted. So that is the only case where virtual erect image is formed, when the object is placed between pole and focus. Okay, these are the all the cases. And when you get the magnification negative, when the image is real inverted, and you get the magnification positive when the image is virtual erect. Okay, So these are the all the cases, okay, we discussed for the concave mirror. Now we are going to discuss about convex mirror. Okay, so see here. So we discuss all this concave mirror. Now we are going to discuss about convex mirror. And what is the convex mirror and these rules? So see, this is our convex mirror, where the here we see that this is pole, this is focus, and this is center of curvature. And here are only two cases when because no pole and focus and center of curvature are not present here. That's why we take only one case when object is placed when object is placed in front of mirror, in front of mirror. Okay, so here the object OA. Okay, and first of all we see the rule. Okay, rule are same. First of all we discuss the rule. When light ray is coming parallel, then after reflection they will pass from the focus, and here is focus here, so this light ray reflect like that. Okay, this light ray reflect like that, and after we produce, it will meet at focus. And this mirror is also called diverging mirror, because when the light ray is coming parallel, then this mirror diverges this light rays. That's why this mirror is also called as diverging mirror. So rule number first, when light ray is coming parallel, then it will pass from focus, and it will look like a diverging mirror. Okay, and second, when rule number second, when light ray coming to the focus, suppose this light ray coming to the focus, then after reflection it will pass parallel to the principal axis. The same rule, when light ray is coming to the focus, then after reflection they will pass from the principal axis. This is our rule number first. Okay, this is our rule number second. Okay, now we are going to discuss about rule number 3, and the rule number is 3 is that when light ray is coming to the center of curvature, then it will bounce back to the same path as it will incident. Okay, and the rule number 4 and our last rule, which is that when light ray is coming to the pole with same angle, then it will bounce back with the same angle. Okay, this is our rule number 4. This angle theta, then this is angle also. So we have to learn these 4 rules. We have discussed for concave mirror also. Okay, and now we are going to discuss our case first, when object is placed in. Here there are no 5th and 6th cases as concave mirror formed, because here pole and focus are both right side of the convex mirror. That's why we are taking only 2 cases. First case, when object is placed in front of convex mirror. So see here, this is our convex mirror, and here is the focus, and here is center of curvature. Okay, and suppose this is our object OA, and when light ray is taking parallel to the principal axis, then after reflection it will pass from the focus. So this image is formed. Okay, and here we are taking the rule number 3rd, when we are taking light ray to the incident ray. When incident ray is coming to the center of curvature, then it will bounce back to the same median, and these light rays are diverging, so never meet. So we produce backward, and this reproduce backward, and these light rays meet at a point, and this point is called our virtual image. So O dash A dash is virtual image of this object. So image is virtual and erect. Second point is image is formed behind the mirror. Image is formed behind the mirror. Okay. And third point is that the here is OA object and O dash A dash is image, and image is virtually erect. Image is formed behind the mirror, and the size of image is smaller than the object, means dimness image is formed. Dimness image is formed. And now most important point, and which is last point, that magnification. And magnification, we said that height of image to the height of object, and this is height of image and height of object, and we see that height of image is smaller than the height of object. Suppose the height of object is 4 and height of image is 2. So here we take both the sign positive, because both are the object and image formed upper part of the principal axis, and upper part of the principal axis we take positive. So magnification is 1/2, means magnitude of the magnification is less than 1. Magnitude of the magnification is less than 1. See, ठीक है, image is formed lesser, ठीक है, magnitude less than 1. And here we see the second point is magnification is positive. Okay. So and last one more case we have to consider, when an object is placed at infinity. Okay, so we take this case also, and then we go for the conclusion of the all the cases. Okay, so this is our convex mirror, and in convex mirror, when we put, this is focus and center of curvature, when light ray is coming parallel to the principal axis, mean when the object is placed at infinity. So we see that when object is placed, then image is formed diminish size. But when object is placed at infinity, then image is formed at focus. Why this image is formed focus? Because this light ray reflect, and this light ray is also reflect, because when light ray is coming parallel to the principal axis, then after reflection they will pass from the focus. That's why this divergent ray reproduce backside, and they meet at the common point, and image is formed here. Okay, so image is formed beyond mirror. Image is formed beyond mirror. Size of image highly diminished, point size. Here we said that the object is formed, image is formed here. So image is highly diminished. You can say that point size image. Next point is image is formed behind the mirror. Image is formed inside the mirror. You can say inside the mirror. Image is formed inside the mirror. Image is formed inside. And most and last important point, magnification. And magnification formula is height of image to the height of object. And image, we know that the image is virtual. Image is virtual. We see here, image is virtual, and virtual image is always erect. And we know that in case of virtual image, magnification is always positive, and mode of magnification is lesser than 1. Why? Because it is highly diminished. Okay, So these are all the cases of the convex mirror and concave mirror, and I will give you last one point for the conclusion. How you learn for the numericals, this all the things in one point. So for the magnification you can find easily. I will show you. When magnification is negative, you directly say that when magnification is negative, the mirror is concave mirror. Directly you can say, okay, when magnification is negative, you directly say that the mirror is concave. But when magnification is positive, then maybe it is concave mirror, maybe it is convex mirror. Okay, but when the magnification is lesser than 1, then this is convex mirror, and when magnification is greater than 1, this is concave mirror, because we know that magnification is positive in last case where we get the virtual image and magnified image. So magnification is positive but greater than 1. Here magnification is also positive but less than 1. So when magnification is negative, you always say that it is a concave mirror, but when magnification is positive, maybe concave and maybe convex. But when concave mirror, then magnification is magnitude of the magnification is greater than 1. Here magnitude of the magnification is lesser than 1. These are all the case, and on these cases we are going to discuss in next lecture our numerical. Thank you.